transistor biasing. In order to work a transistor as a switch or as an amplifier, we must first set its DC circuit conditions properly, namely the proper zero signal collector current, proper base emitter and collector emitter voltages. This process is known as transistor biasing. There are different transistor biasing methods. Some of them are base resistor method, emitter bias method, biasing with the collector feedback resistor, and voltage divider bias. Base resistor method. In this method, we are connecting a high resistance RB in between base and plus VCC. This plus VCC provides necessary zero signal base current in the circuit. When a current IB flows through RB, it makes the base emitter junction forward biased. Due to this IB base current, there will be sufficient collector current, which is beta times IB. So IB is IC by beta. We want to calculate RB also. So for that, we have this VCC equal to IB/RB plus VBE, Kirchhoff voltage law. From that, RB is equal to VCC minus VBE by IB. Now the stability factor. Stability factor is the ratio of collector current IC with respect to collector leakage current ICBO at constant beta and IB. That is, stability factor S is equal to DIC by DICO at constant IB and beta. This ICO also means ICBO, that is the leakage collector current in the common base configuration. Sometimes ICBO also referred as ICO. So the general expression for stability factor in a C configuration can be calculated as follows. We know IC is equal to beta IB plus beta plus 1 ICBO. Now we are differentiating this with respect to IC. You are getting 1 is equal to beta DIB by DIC plus beta plus 1 DICO by DIC. But DICO by DIC is 1 by S. Therefore, S is equal to beta plus 1 by 1 minus beta DIB by DIC. If DIB by DIC is 0, that means IB does not change with change in collector current. Okay. In the case of base resistor method, we have an IC and the IB is independent of IC. Therefore, we can directly calculate RB. So sometime base resistor method is also known as fixed bias method. So in fixed bias method, DIB by DIC is 0. Therefore, S is equal to beta plus 1. The fixed bias method or the base resistor method is a simple method. It uses only one resistor RB and it does not have a base resistor, so that the circuit will not load any source, and it have very poor stabilization. The stability factor S is very high. We know that the value of beta is very high, so stability factor is very high. Stability factor is very high means there is a chance of thermal runaway. Voltage divider bias. In voltage divider biasing, we are using two resistors R1 and R2, which constitutes the voltage dividing here. That's why the name voltage divider biasing. So the voltage across R2 will provide necessary forward bias condition for base emitter junction. Here also we can analyze the circuit. The collector current, okay, this is I1 is equal to VCC by R1 plus R2, and voltage across R2, this one R2 V2 is I1 into this R2, that is VCC by R1 plus R2 into R2, that is voltage across R2, we call it as V2. Now applying Kirchhoff voltage law, V2 is equal to VBE plus VE. V means IRE, or V2 is equal to VBE plus IRE. From that, IE is equal to V2 minus VBE by RE, and we know IC is approximately equal to IE, that's equal to V2 minus VBE by RE. Collector emitter voltage VC is VCC equal to ICRC plus this one, VCC equal to ICRC plus VCE plus IRE. From that, VC is equal to VCC minus IC into RC plus RE. Here also I choose IE is approximately equal to IC, that is VCE. Stability factor is given by beta plus 1, 1 plus RO by RE divided by beta plus 1 RO by RE, where RO is R1 R2 by R1 plus R2. Suppose RO by RE is very small, then S is equal to beta plus 1 into 1 by beta plus 1. We can neglect this value. So it is approximately equal to 1, but practically its value is different.